These decoders and encoders, these are the two combinational circuits which are going to take n inputs and produce m outputs. We'll examine this one by using one example, that is 3 into 8 decoder and 8 into 3 encoder. We'll use two blocks. One block is going to take 3 inputs and produce 8 outputs, and those will be input to the next block that will take 8 inputs and produce 3 outputs. The left block is called as a 3 into 8 decoder and right block is called as 8 into 3 encoder. The decoder takes 3 inputs, n is equal to 3, and produce 2 raised to 3 outputs, m is equal to 2 raised to 3 is equal to 8. The encoder is going to take n is equal to 2 raised to 3 inputs, that is equal to 8, and produce m is equal to 3 outputs. We'll examine this one by using a truth table. This truth table is a decoder and this truth table is a encoder. Decoder takes 3 inputs and produce 8 outputs, D0 to D7. Encoder takes 8 inputs, D0 to D7, and produce 3 outputs, X, Y, Z. We'll examine by using an example, that is 6110 in binary. And if X, Y, Z are 110, it will produce D6 as equal to 1. This is it. D6 is equal to 1. We'll use a circuit diagram for this one, which is made up of AND gates. AND gates are used in decoder, and here 3 inputs are there which are going to have a normal input as well as complemented input. X is a normal input, complemented input. Y is a normal input, complemented input. Z is a normal input and complemented input. Here in example, X1 and Y1 and Z0. X is 1, it is a normal. Y is 1, it is also normal. Z is 0, it is not normal, it is complement. Hence you are going to have a X, Y, Z complement. X1, Y1 and Z complement is equal to 0 complement means what? It is 1. So this output is 1 and rest others are zeros. Okay, this is a decoder. The encoder, what we are going to have is a encoder that takes D0 to D7 as inputs and XYZ as outputs. X is going to be 1 for respective D values. Y is equal to 1 for respective D values. Z is equal to 1 for respective D values. We'll examine by using an example, that is Z. Z is only because D1 is 1, D3 is 1, D5 is 1, and D7 is 1. So combining all these 4 values, we are going to use a formula, that is Z is equal to D1 plus D3 plus D5 plus D7. Similarly, Y is going to have D2 plus D3 plus D6 plus D7, and X is equal to D4 plus D5 plus D6 plus D7. This is the encoder, and we are going to use this same in the circuit diagram. Here are the inputs and here are the outputs. We have used the OR gate here because there is a plus. This is encoder.